In this video, we will be interpreting p-values, learning how to interpret p-values. Well, first start with our definition. P-value. Assuming H naught is correct, p-value is the probability of getting the sample or our particular test statistic. These are synonyms essentially. The sample produces the test statistic or more extreme. Assuming H naught is correct, p-value is the probability of getting the sample that we got or more extreme. Let's look at a particular example. Alright, example number 1. We've seen this mean height of adult American women before. Let's assume that mu is the mean height of adult American women. Mean height U.S. women measured in inches. Alright. Assuming that the mean height of the U.S. women is 64.5. Well, let's say that we think that our women in Jacksonville are taller. We feed them better, or the water is better, or the environment's better, whatever. We have the research hypothesis, the alternative hypothesis, that the mean is greater than 64.5. Okay, so we might go out there and take a sample, measure those women, find the mean, and then try to make some decision based on that. So let's say that we have a sample of size 4. We measure those 4 women, and indeed they have a sample mean of 66. Maybe one was 67, one was 65, one was 68, one was 64. We add, divide by 4. The mean for this sample was 66. Well, what is the chance of getting this 66 or more extreme? In this case, that p-value is 0.115. All right, and this is you can read this as a percentage. That's 11.5%. What does this mean in this context? Well, I'm simply going to fill in the blanks here. Assuming H naught is correct, so in our context, assuming the mean height of U.S. women is 64.5, if the mean height of U.S. women is 64.5, and what I don't have here is the standard deviation of 2.5. It's sort of implied in this case. If the mean height of U.S. women is 64.5, that's our assuming H naught is correct. P-value is the probability of getting the sample or more extreme. Well, our p-value is 11.5%. So I would say there is an 11.5% chance of getting our sample. That is a sample of size 4 with a mean of 66. There's 11.5% chance of getting a random sample of 4 women with a mean height of 66 inches or greater. This is the more extreme part. 66 inches or greater. There's an 11.5% chance of getting a random sample of 4 women with a mean height of 66 inches or greater. That's what the p-value means in this context. So, while indeed we did get women that had a higher than 64.5, it just wasn't convincing enough evidence. We only chose 4 women. We might have gotten lucky and gotten the right 4 women. We might have gotten one woman that was extraordinarily tall and the rest of them short. So, since there were so few women in this case, the evidence was not all that compelling. All right, let's change these numbers and look at it again. Okay, example 2. Alright, same null with the same alternative hypothesis. We believe that women are indeed taller than that in Jacksonville or wherever. We could say in the United States, where we're saying doesn't really matter. With the same definition, we're talking about mean height. But this time, instead of having 4 women, let's say we chose 20. And indeed, we got the same X bar to be 66. Well, this is way more compelling evidence. Here we only got 4 women. You know, maybe we had one woman that was particularly tall, but here we got 20 women. Now we have 20 women, and we're a whole inch and a half above the mean, and our standard deviation is only 2.5. So 20 women is pretty substantial. In this case, the p-value, you could use your calculator and verify this. The p-value is approximately 0.004. In this case, that is 4 1,000ths. All right, 0.004 is 0.4%. And said another way, that's 1 in 500. Okay, so I'm not going to rewrite it. I'll just use my statement here and change the particular numbers we have. If the mean height of U.S. women is 64.5, there is an 0.4% chance, or a 1 in 500 chance, or a 0.004 chance, any way that you want to state that, of getting a random sample of 20 women with a mean height of 66 or greater. So in this case, it's very compelling evidence. We would reject H0 and go with HA. In this previous case, with an alpha of 0.05 or even 0.10, we would fail to reject. So here is very compelling evidence. Here is not so compelling evidence, and the only difference is our sample size. We had the same mean. Clearly, it's more compelling to have 20 women with this mean height than just 4. I'm going to write one more example down, and I want you to attempt to interpret it. Example 3. All right, let's say that our H0, let's use a proportion this time. Our H0 is that P is equal to 0.25, and our HA is P is less than 0.25. And let's define P to be the proportion of adults who attended church in the past week. All right. So we're assuming that 25% of people have attended church in the last week, and our alternative hypothesis is no, people are not going to church that much. The proportion is actually less than that. Let's say we take a sample. All right. We have a p hat, and in this particular sample, 1 out of 10. 1 out of 10 went to church. All right, so obviously that is 10% or 0.10. Okay. What is the p-value associated with that? Well, I'm going to use my calculator to find. And it turns out that my p-value in this case is 0.13. Alright, you see if, pause the video at this time and see if you can interpret this particular p-value. Okay, our interpretation of our p-value. We start with assuming H0 is correct. Assuming .25% of adults attended church in the last week. There's our assumption. The chance of getting our sample, the chance of getting a sample of size 10 where only one person went, is 0.13. So I'm going to start with that. There is a 13% chance of getting a sample, a random sample of size 10 where one or fewer, so in this case that's only 0, where one or fewer, there is a 13% chance of getting a sample of size 10 where one or fewer went to church. When we're doing this to interpret, when we're dealing with proportions, it can be slightly confusing because we're seeing percentages twice. Once in the context of our parameter and once in the context of the probability. Assuming 25% of adults attended church in the last week, there is a 13% chance of getting a sample of size 10 where one or fewer went to church. That is, it is compelling, all right, but probably not by, certainly not by our 0.05 alpha or even by our 0.1. Our sample size is just not that great. All right. That concludes this video.